Here we'll look at how to find a sample size that you need to estimate mu. So if we look at our margin of error in our confidence interval formula, that's z star times sigma over the square root of n. If we solve that for n, that'll find the minimum sample size we need to estimate mu. And we're always going to round up to the next integer. So we just take that formula, do the algebra to solve for n, and I'll just quickly uncover the steps here. So if you cross multiply by square root of n, so basically multiply both sides by square root of n, you get this. And then we want to get n equals, so we'll divide by e. So that'll give you square root of n equals z times sigma over e. And then to undo the square root of n, you square both sides. So we have n equals z times sigma over e, that whole quantity squared. Okay, and we do not round until the final step, and we always round up to the next integer. The idea there is to get a minimum sample size. If you end up with an n value of, say, 84.3, you cannot choose 0.3 items. So you round up to the next whole number integer. Okay, so just a few quick examples of this. Pause the video if you need to read through this whole thing. I'm not going to read it, but I'll go through the calculation here. What is the minimum sample size needed? So minimum sample size, that means we're trying to find n. So we're going to take our formula here, and that means we need to know what z, sigma, e are for this example. Okay, so the z value always comes from how confident you want to be, your confidence level. So the z-score for a 90% confidence level is 1.645. Sigma, when you read through the question, it says in that third sentence, assume the population is normally distributed with the standard deviation of 3 years, so sigma is 3. And you want your estimate to be within 0.5 years, so there's your margin of error, 0.5. Okay, so when you plug all those in, it's just putting it in your calculator. You get 97.4169, so you have to round that up to the next integer, 98. Okay, question 2. This gives you a different example, and it wants you to find the minimum sample size needed for 2 different confidence levels, a 95 and a 99 level of confidence. So this is just applying that formula twice. Okay, so I suggest you pause the video because I'm going to put the answer up here because it's very straightforward. So pause the video if you need. Okay, and there's your solution. So remember the 1.96 and the 2.575, the z values, those are the only things changing here because the only thing changing is your confidence level. And the only other thing I'll point out here is that notice that your larger confidence level, the 99% confidence level, you end up getting a larger sample size that you need. Mathematically that happens because 2.575 in the numerator here is larger than 1.96. So when you do the arithmetic, you're going to get a larger answer. Now, what that's really doing though, the reason why 2.575 is larger than 1.96, well, that's just math. That's 2.575 is larger. But the reason 99% gives you that larger value is because if you want to be more confident, you have to go farther away from the mean. Remember that these numbers are z-scores. So if you want to have 99% confidence, you need to be farther away from the mean than you do for 95% confidence. So that's why that number is larger.